Hi students, today we are going to look at a derivation, that is motion of a charged particle placed in a uniform magnetic field. Here in this diagram, Q is a charge which is kept at three different positions, P, Q and R. Here we must remember that this charge is moving with a velocity v. But this moving charge particle is kept or placed in a uniform magnetic field which is acting along z-axis at different positions. Okay, now the principle behind this. Any moving charge particle placed in an uniform or magnetic field experiences a magnetic Lorentz force. Here, in this diagram, F is the Lorentz force which is acting towards the center. In the diagram, at different positions P, Q and R, this F is acting towards center, V is acting along this direction at this point, along this direction at this point, along this direction at this point. Here, F is the magnetic Lorentz force, B is the magnetic field along z-axis, V is the velocity as shown in the diagram, Q is the charge. Now let's see the formula for magnetic Lorentz force. Here, F vector is equal to Q of B vector cross V vector, or F is equal to BQV sin theta. Theory. Since B, Q and V are perpendicular to each other, here theta is taken as 90 degree, so F becomes BQV. Now in the diagram, the Lorentz force F vector acts towards the center O. This force does not do any work on the charged particle. Instead, it provides a centripetal force. We all know that the centripetal force makes any object to move in a circular path. We also know the formula for centripetal force F suffix C, which is equal to mv squared by r. Here, m is the mass of the charged particle, v is the velocity of the charged particle, and r be the radius of the circular path. Derivation. Since the magnetic Lorentz force provides a necessary centripetal force, BQV is equal to mv squared by r, here VV gets cancelled, the equation becomes BQ is equal to mv by r, or else we can write it as BQ by m is equal to v by r. We already know the relation between linear velocity v and angular velocity omega. So v is equal to r omega. From that relation, we get v by r is equal to omega. So here, bq by m is equal to v by r, which is equal to omega, which is taken as equation 1. We also know that the angular frequency omega is equal to 2 pi into the linear frequency nu. Here, nu is equal to 1 by t. So omega is equal to 2 pi into 1 by t. Here bq by m is also equal to 2 pi by t, or else we can find out the time period of the revolution of the charged particle. Capital T is equal to 2 pi m by bq, which is taken as the equation 2. Also we know that the linear frequency is equal to the reciprocal of time period 1 by t, which is also equal to bq by 2 pi m. This is taken as equation 3. In equations 2 and 3, there is no v, that is velocity, as well as the radius r. So it means that both time period t and linear frequency nu does not depend on the velocity of the particle and also the radius of the circular path. Here, as velocity increases, the radius also increases, but time period remains the same. Some interesting facts in this derivation. If the sun is at the center O and a planet is at different positions P, Q and R, then instead of Lorentz force, the sun's gravitational force provides the necessary centripetal force for the planet to move in a circular path. Okay, if this Lorentz force does any work on the charged particle, then the particle moves towards the center and there is no circular motion at all. As the velocity of the particle increases, just when we tie a metal bob to a rubber band and rotated it above the center O, what will happen? As the velocity increases, the radius of the circular path will also increase. So, as the velocity of the particle here increases, the radius of the circular path will also increase. Here, whatever be the velocity and radius, as in equation 2, the time period t will not change at all, it will be same, that is always constant. I think you would have understood this concept. Thank you.